please do focus. So especially the matchings, no. So these are the very important ways of asking questions, especially in maths, the following. Not just numericals. I think a student must also think not just end answer, what actually goes on in the numerical. Okay, this is the thing. What about the friction? So this is the acceleration, what we are plotting. So minus omega square A. I'm interested in the friction. So friction will vary similar to the acceleration only. So what we have a curve. So similar to that, the friction curve is going to vary. This is the maximum friction. It varies harmonically. This is something very important. So what is this F? Rolling friction. It's, I think, first time you come across graph of friction of like this. Now, for any amplitude, will it oscillate? Say the questions are very important in books. What when we have a question, time, find the time period. Okay, everyone will do that. What is there? So something questions when they are asked about the more than one options, no, along with the time period, I will do ask other things here. For any amplitude, will it oscillate? Anybody wants to answer? What is the maximum possible amplitude for which the body will oscillate? And we do have one more word, no? Friction sufficient for pure rolling. How to justify these two? As in fact, there's a thing. What is x equal to? X equal to a cos omega t, shall we write? And what is the maximum permitted value of friction? Mu s mg. What is the maximum permitted value of rolling friction? So F is equal to minus IC omega square R square A cos omega t. Then what is the maximum permitted value of A max is asking. So when this will become limiting. Cos omega t should be equal to 1. So what is FL? Mu s mg. Negative sign. I'm. So what is A max? A max equal to mu s mg r square by IC omega square. Omega value we know time period from there. There's a thing about the omega. Okay, substitute the time period. So that will determine the maximum thing that one. So for all values, if the amplitude of oscillation is less than this, the friction will be less than limiting and there won't be slipping. If the amplitude is greater than this, slipping will occur. It will not be SHM, damped oscillations, what you can call it. What is omega? Omega is this particular thing. We have to bring it. We have to solve like this here. In this one, omega, it has to be brought from here. Omega square is asking. Okay, substituting that, we can solve here. Getting the idea? I think if I substitute omega square, okay, let me substitute omega square. I see omega square will be kr square r square get cancels. Okay, fine. This is the amplitude. So very important. Please do remember in books they didn't stress. So what shall we write? If A less than Mx, no slipping. If A greater than Mx, okay, sorry, no slipping or pure rolling occurs. Then yes, slipping occurs. Sorry, A greater than Mx. A greater than Mx, slipping will occur. Will it be SHM? Here it will be SHM. Motion is SHM. What about here? Slipping occurs. The motion will be in fact damped oscillation. Energy will not be conserved. The amplitude will keep on decrease and finally come to rest here. Okay, I just wanted to give the exact idea of this particular rolling. There's a one basic problem I picked up. It can be any rigid body. Springs can be connected anywhere. Okay, this is about, I think it's quite lengthy, so like we should know all these things. Shall we solve this by any other approach? So let's take the intermediate position. So if you take this intermediate position, what all form the energy is available here? In what all form energy is available? The energy is available in the form of rotational kinetic energy, translational kinetic energy, and elastic potential energy. And from where this energy will come, the oscillation energy from here, the extravagant what happen will drag this disc. For this what happen, the spring will get elongated. And that is what oscillation energy. The moment if I release here, because of spring force and friction, it starts rolling. Then it will execute SHM. This is what happens here. So now shall we go for energy method? As in what all form energy is there? Rotational kinetic energy, translational kinetic energy, and elastic potential energy of the spring. Okay, let's do by energy method. One spring, okay, energy method is preferable. More than one spring, no. So it's better to go for energy method only. If one spring, that torque method will be much easier. So the oscillation energy is equal to mv square mv square. What is E naught? E naught should be equal to Ka square by 2. This is oscillation energy or work done by an external agent. Okay, then what is V? V equal to R omega. I think I wrote many times. Huh? Let me write here. V equal to R omega, and in fact V equal to dx by dt. Let me replace all the things. So E naught is equal to mv square by 2 ic by 2. Omega will be v square by r square equal to k by 2 x square. So this will become mv square. And okay, I had to differentiate, no? This one. So dE naught by dt, m by 2, 2v dv by dt, ic 2r square, 2v dv by dt, mva plus ic. Now why? Because overall mechanical energy remains constant, what all we supplied. So that V will get eliminated from the equation. So this will become MA plus IC R square A the same equation what we earlier we had. Okay, now look at the both the answers. IC plus mr square by kr square. IC plus mr square by kr square 2 pi. Energy method. Tell me like which one you fill. Either one you can prefer. Depend upon your convenient. That's what I said. Depend upon your convenient, you can go for the either one. No, no. What is the maximum angular velocity? Can we find out that omega m? Again, applying conservation of mechanical energy. Can we calculate this omega m? Maximum angular velocity of this one. So here in what form the oscillation energy is of Ka square. The same energy is available here in the form of kinetic energy and rotational kinetic energy because the elastic potential of spring will be zero. Since Vm equal to R omega m. See, so many things can be asked here. A student has to not just only time period. Along with this, so many other things are there which you are supposed to learn. Okay, got the idea? So look at this one's energy method. I think this you are quite very familiar, no? The energy what we supply, that is oscillation, and that will remain same because SHM is a motion which will obey the law of conservation of mechanical energy principle. Fine. Okay, let's take the application part. The basic idea I started from here. Okay, now if you have so if it is like this,